My name is Ekele Michael, an engineer and a technologist in the Department of Electrical and Computer Engineering. Today we shall be doing a very simple experiment, and this experiment demands that students should be attentive to avoid making mistakes during practice. The title of the experiment is Half-Wave Rectification with and without filter. The aim of the experiment is to examine the input and output waveforms of half-wave rectifier and also calculate its ripple factors. Apparatus needed for the experiment. 1. A step-down transformer, 6-volt center tap. 100 microfarad capacitor. 1 kilo ohms resistor, which we shall be using for the load resistor, and a diode, 1N4007 diode is also required, and few jumpers for connection. A breadboard is also required in this experiment, and also an oscilloscope to view the waveform that we shall be seeing in this experiment. Step 1 of the experiment is to make connections on our breadboard as seen on the board. So let's make our connection on the breadboard. First of all, connect our transformer. This is the positive side of the transformer. Connect with this point, and then the negative is at the middle, so we'll connect it to ground on our breadboard. We're using this part of the breadboard for ground. We'll connect our diode in forward bias mode as shown in the diagram. The load resistor is connected to the diode and also is grounded. For us to calculate the ripple factor without capacitor filter, we'll first of all get our VM for this waveform. The VM is the tip of the waveform that we have here, and the corresponding value to it on this vertical axis on our oscilloscope. Now, if we look at it, we have this wave is cutting through 3 boxes on the oscilloscope, 1, 2, 3. Okay, and then our oscilloscope knob here is on 2 volts. That means our VM, we have our VM, which is equal to 3 multiplied by 2. 3 boxes in which our wave is cutting, and then the 2 is the volt on the oscilloscope where our knob is set, or 6 volts. And then our VDC, is equal to VM all over pi. This leaves us with 6 divided by 3.142, which will give us a value of 1.91 volts. The formula to calculate the ripple factor is R all roots .46. Here we have 1.46 as our ripple factor. We'll come back to our circuit where we shall be adding the filter to it and also calculate the ripple factor of the circuit using filter. We'll add our filter to it. The filter is connected in parallel with the load resistor. Having connected the capacitor, we are expected to view the output of our waveform with capacitor filter. We could see the changes that was observed in our waveform, okay, and the value of our VR is the little ripple that is here, that we have here, up here, which is about 1.2 from our oscilloscope. Alright, to get our V sheet, we'll ground the signal and then take it back. The value in which it shifted from this point to this point is what is the V shift of the wave. To calculate our ripple factor with capacitor filter, the ripple practical factor is given as V ripple all over VDC ripple, where our V ripple is VR all over 2√2, and VDC ripple is V shift plus VR over 2. From our oscilloscope, we observe that our VR is equals to 1.2 and is on 2 volts as our oscilloscope, so we multiply this by 2. This will give us 2.4, and our V shift is equals to Vm minus VR. Our Vm is 6 and our VR we have here. This leaves us with, okay, we'll first of all calculate our V ripple and our V shift. V ripple is equals to VR all over 2√2, which is equal to 2.4 all over 2√2. This leaves us with 0.84, and our VDC ripple equals to V shift plus VR over 2. Our V shift we have here VR this leaves us with a value of a value of 4.8. The practical value in which we are most interested to calculate is R, practical, B, ripple, all over VDC ripple. We have the values above. We impute the values, which we're going to have 0.84 divided by 4.8. This leaves us with 0.18. 0.18 is the value we are having as our ripple factor when we have capacitor filter added to it. And also to calculate the theoretical factor is given in this manner. Is given in this form with this formula. Okay, 1 all over 2 root 3 frequency multiplied by capacitor value multiplied by resistor value. Here we have 1 all over 2 root 3 multiplied by 50, which is the frequency of the transformer we are using, multiplied by, we are using a capacitor value of 100 microfarad, 100 microfarad, and the value of our load resistor is 1 kilo ohms, which is 1 times 10 raised to power 3. And this leaves us with a value of 0.06. With this, we can see clearly the differences in the values that we have calculated. When we have no filter to it, without filter, we're having a value of 1.46 as our ripple factor, and when we added filter to it, we have 0.18. This has shown us clearly that we can reduce ripples in our circuit using capacitor filter. Students are advised to use different values of capacitor and different values of resistor in this particular experiment to see how well you can reduce ripples in a circuit. We also have laboratory questions that you answer at the end of this laboratory, which will make you to understand this lab very, very well. Thank you.